All right. So we're going to go over some stuff for Unit 1, talk about geometric sequences and series. Before we get to that, let's just review some basics. What's a sequence? Essentially, a sequence is just like a bunch of numbers in a pattern in a row. Okay? We're not going to, let's make it that. A series is when you take this pattern, whatever sequence you have, and you find out the sum of the numbers. So this is term 1, n equals 1. This is term 2. This is term 3. So if I had the sum at 1, it would be 1. If I had the sum at 2, it would be these two numbers added together. So in that case, it would be 4. And then again, sum at 3 would be when you add all three numbers together, so that's going to give me 9. Okay? That's the key difference to understanding. And when you're using formulas, if you want to just know what number is in the pattern, you're going to use the first one. If you want to know what the sum is, or it asks for a series, you're going to use the second one. So, geometric. Last time, you talked about arithmetic, which is when you had patterns like this. This is where the pattern is increasing by adding a number. In this case, we're adding 1 every time. We're not going to talk about those right now. Geometric is instead of adding numbers, we're multiplying every time to change between the terms in a sequence. So for example, it's pretty easy to tell looking at these numbers, what are they multiplied by? It's multiplied by 2 every time, which means that R is our ratio. That is what's multiplied every time. In the last one we talked about D, that was the difference. So in this case, the D would have been like +1. So we need to be able to figure out R. The way you can do it, if you can't just tell by looking, is you take the nth term and divide it by the nth minus 1. So it would be like 8 divided by 4. So like the number divided by the number that comes before it. 8 divided by 4, 2. Oh, well, that means I multiplied by 2. In the second one, we can see they're getting smaller, which means we're not multiplying, we're dividing by 2. So we don't like to think of it like this, because then some kids will make a mistake and say, oh, well, R is 2, we're just dividing. It has to always be multiplication. So the idea is that we're not dividing by 2, we're actually multiplying by 1/2. Okay, so in this case, the R would be 1/2. And as you can see, they're getting smaller. This last example is a little weird because we have a negative number. So don't get freaked out by the negative number. What I usually do is try and figure out the number first, so I can tell, okay, well, it's getting square root every time, right? It's divided by 3. So we got divided by 3, divided by 3. Okay, so I know my factors could be times a third, but see how it goes negative? That's the pattern. It was positive, negative is going to be the next one. So that means that it's actually going to be negative 1/3. The term that we're multiplying by is negative 1/3. So it's going to switch between positive and negative. That's allowed. That's okay. So our R for this one's going to be negative 1/3. So being able to identify what the R is when they give you a pattern is really important, as well as like know what they talk about when they say series or sequence. Convergent and divergent. We can look at these patterns to kind of figure out what that means. Converge means like to come together, to get closer. Divergent means like to go apart, far away. So the idea is when we look at our patterns, are the numbers getting closer towards a final answer, or are they moving farther away? So when we look at these ones, 1, 2, 4, 8, those numbers are getting bigger and bigger. If I was going to draw a graph for it, it would look like this. Numbers start like this, and it keeps going like this. It would get exponentially bigger. It's divergent. It's never getting close to anything. Okay? The second one, they're shrinking. And you can see it's dividing by half every time. It's getting closer, closer, closer. It's actually getting closer to 0. It'll never actually get to 0 because you can't divide by 2 to equal 0. So that one would be convergent. This second one, it's flipping all over the place, and our graph actually ends up looking like this. Started at 27, and then went to -9, and then 3, and then a third, and it'll actually look like this. This one's convergent too, because it's getting closer to 0. And what you maybe noticed is that the R term, if it is a fraction, it's going to be convergent. And when I say fraction, I mean it's in between 1 and -1. So it's like 0 point something something or -0 point something something. Those ones are the convergent ones where it shrinks. Anything where it's bigger, so if you have an R of like 3 or an R of -5, anything like that, or even if it's an R of like -6 over, I don't know, 5, that's greater than 1, right? Those are all going to be divergent, where it's going to get extremely bigger, even if it's a negative number. So like this one would actually work like this. So it starts with this number, and it gets bigger and bigger and bigger and bigger, farther away from the 0. Those are the basics. These are the formulas right here. These are the formulas that you need to use for basically every question. Oops. Oh, well, that's okay. These are the formulas you need to use for every single question. I'm going to move them down so that we can see them while we do some of these questions. All right. Like I said, the first one is if we're trying to just find a term. The second one is if we're trying to find the sum, sequence, series. So in this question, it's given us the sequence. It gave us some terms. It wants us to determine T7 and T9. So what you need to do for every single question is figure out which equation am I going to use, and then what information do I have. So I know I want to find T7. It's not asking for anything about SN or sums. So I'm not going to use this one. So let's try and use this first formula. So I like to look and see what we have. Do I have Tn? Well, yeah, I guess I could use like T3 as my Tn. That's fine. Do I have T1? I don't. Do I have my R? It didn't give it to me. And I do have N, because in this case it would be 3. So I don't have enough information yet. I need to find either T1 or R. So usually R is the one that you can calculate if they give you multiple terms. So let's try and write it out so we can see it. T3 equals 9. T6 equals 1.125. So the idea is, we know that it got multiplied 3 times to turn into this number. I know it's going to be a decimal because it's getting smaller. It's going to be some kind of fraction. We need to figure out what did it get multiplied by so we can see it. So we can actually do it like this. Let me grab my calculator. So I did 9 divided by 1.125, okay? And it gave me 0.125. So that's what it was multiplied by. But now what we have to do is we have to cube root it to find out what each term would be. So when I cube root that, I get 0.5. So that's going to be my R value. That's what it was multiplied by. And we can check, right? So half is going to be 4.5. Half of that's going to be 2.25. So that'd be T4 is that, T5 is that, and then T6 is 1.125. So that worked. That was our process of finding the R value. Awesome. So now we have enough information to use the formula. So let's actually write it out. So I don't know what T1 is yet. I want to find that before I start trying to figure out T7 and T9. So let's figure out T1, the first term in the sequence, by using this formula. So we got Tn equals T1 times Rn minus 1. We're going to use the T3 just because it's easier. So I have 9 is equal to T1, I don't know what it is. R we said is 0.5. And then n minus 1 is going to be 3 minus 1. So 9 is equal to T1 times 0.5 to the power of 2. So 9 is equal to T1 times 0.25, pretty sure. Yeah. If I mess that up, that would mess up the rest. Okay. Now I'm going to divide both sides to cancel out the 2, 5. Okay. I get T1 is equal to... Sorry, 36, which makes sense because it should be a bigger number getting smaller every time. So I found my T1 now. Awesome. Go back to the question. What did it ask me to find? Well, T7 and T9. So what I need to do now is I need to use the formula again with my 36. So I can say T7 is equal to 36 times 0.5 to the power of 7 minus 1 is just 6. So when I sub that in the calculator, to the power of 6 times 36, I got 0.5625. Cool. That's T7. And then for T9, I would do the same thing. There is another way you could do it. I could just look at this pattern and just multiply again by the 0.5 to find out the next term. It's up to you to figure out like what strategy you want to use. I use the formula because there's going to be hard questions where you have to use the formula. Okay? So that's the basics of that question. Though that's a pretty straightforward one. This one's a little harder. This identify the terms. It's harder because it's using a series. Let's move it this way. Okay. Identify the terms in each partial sum of a geometric series, and it gave us the numbers. Here we go. Okay, so when it says identify the terms, that means it wants us to list what the terms are in a list. It says it's S5, so that means there's 5 terms, so I know I'm going to have to list the first 5 terms in the pattern. It gave me S5, so if I look at, I know I'm going to be using a sum formula. So I have the sum, good, and I have R, I have N, because I know it's 5, but I don't have T1, but I have the rest. So I could just use this formula and do it, and it would be okay. So let's sub our information into this second formula and find the answer. So I have 62 equals T1, I don't know that yet. R is going to be 2 to the power of 5 minus 1 over 2 minus 1. Cool. So let's do the math. 62 equals T1 to the power of 2 to the power of 5. So it's 32 minus 1 is 31 divided by 1. So we got 62 divided by 31 equals T1. So T1 equals 2. Cool. So again, it's asking for the list of terms. So I know T1 is 2. So we could use this formula to figure out every single one. That's going to take a long time. So let's just use my R. I know it's times 2 every time. So the next one's 4, and then 8. And then times 2 again is 16, and then 32. And then we have our list, and we're good. We could check our answer by adding them all up to make sure the sum works, but I'm not going to. It's fine. So that's the pattern on how to use it. Again, this entire unit 1 breaks down to, you have your equations. These are the 2 big ones we're going to use for this unit. You need to figure out what numbers you have and sub it in. I want to show this one because it's, oh, sorry, let me, here we go. I want to show one more question because it's kind of tough and a lot of students get messed up by it. So it gave me the geometric series. It has a finite number of terms. It says, how many terms is it? So it's asking for n, I don't know. And it says, calculate the sum. So we want to know Sn is equal to whatever. So most students are going to say, okay, I want the sum. Let's figure out, let's do this pattern. So the only problem is when I look at this one, I don't have Sn. I have T1. I can figure out R pretty easily, but I don't have N. So that means I'm missing 2 numbers. So I can't actually do this formula yet. So what we're going to have to do is that even though we're looking at a series, we're going to do this first formula to figure out what we're missing and then use the information in the second formula. So let's do the first one. Oh, let's figure out R first, sorry. So it goes from 1 to 2 to 4 to 8. So I know it's times 2, but then it's switching between negative and positive. So my R is going to be -2. Sometimes I like to list this stuff at the top just so I remember that I have it. If you want to do that, T1 is equal to 1, and that's basically what we need. So let's use this first formula. So Tn, it actually gave it to us. It gave us the last term. Oh, well, you know what? We don't need to use that because it already... Oh, let's use this equation so we can figure out what n is, like how many terms it is. So Tn, we got -512. T1 is 1. R is, what did we say it was? -2 to the power of n minus 1. Cool. So now the 1 doesn't really matter. So we got -512 is equal to -2 to the power of n minus 1. So what we have to do here, it's kind of tricky, is we have to turn this into a base 2. We have to turn it into something. -2 to the power of something is equal to -2 to the power of n minus 1, right? We've got to figure out what that number is that turns it into 512. So there's a lot of different ways. Honestly, the easiest way is like trial and error to try to figure out. So we know it's going to be 2 times something, so we can look at like what 2 to the power of is that's going to give us 512. And it's actually 2 to the power of 9 is equal to 512. So be very careful here, because what we're saying is 2 to the power of 9 is equal to 512. So that means that n minus 1 is equal to 9, which means that n is equal to 10. So now we found out our n, we can sub it back into the other equation to do the rest. So let's do that now. So now we want to calculate the sum. So s at n is equal to t1 times rn minus 1, r minus 1, and we'll sub in the numbers. So we have, I don't know what the sum is, t1 was 1, r was, what do we say, it was negative 2 to the power of 10 minus 1 over 2 minus 1. So those aren't going to really matter, so it's going to be negative 2 to the power of 10 minus 1. So do that on our calculator. So I got 1024 minus 1, which is the same as 1023. So the lesson for that to take away is that sometimes there's going to be questions where you got to use that first formula to figure something out and then use it in the second formula. I want to reiterate, for every single unit or every single question in this unit, you will use one of these formulas, at least if it's geometric. You just need to figure out what information you have. If it's a word problem, figure out what are they giving you. Do you know what the R is? Can you figure out the R using some of the terms in the list? Do you know what the first term is? Do you actually know what the last term is? Or do you know a term in the pattern? Did it actually give you the sum? So just read carefully and try and understand what they're asking, and you'll be able to do these questions.